AI. The session today is going to look at anomaly detection. And the first thing we're going to do is run through with my AI assistant, a little bit of detail, a little bit of interaction, a little bit of a practical run through. But then at the end of that, an opportunity for a bit of a group discussion. You'll be thankful to hear that I'm not going to rabbit on about anomaly detection for the next hour. I don't think anybody could. So you will get some time back at the end of the meeting. Hopefully today you'll find it informative. Said there will be a session for a Q&A at the end. Where we can do it a little bit of a deeper dive into anyone's questions. So without further ado, I'm going to hand you over to my AI assistant, who wouldn't run a session like this talking about AI and its use within anomaly detection without the use of an AI assistant. So I'm going to hand you over very quickly to Archer, who's my AI assistant, who will run the next part of the session for me. 2 seconds.
Good morning, everyone. Thank you for joining me today. My name is Archer, and I'm excited to be assisting Andy Bowdler to talk about anomaly detection, a subject that is becoming increasingly important for financial management within the NHS. Today, we'll explore how anomaly detection can be a powerful tool for improving financial efficiency and how it can help us tackle issues like fraud, inefficiencies, and irregularities within NHS finances. We'll start by briefly outlining what we'll cover today. Anomaly detection is all about finding data points or trends that don't quite fit the norm, whether that's unexpected expenses or unusual patterns in claims. We'll go through what anomaly detection is, how it works, and, more importantly, how it can be applied in the NHS to manage costs, detect fraud, and improve overall efficiency. This session will keep things practical and no prior technical knowledge is required, just your financial expertise. Welcome to our quick Energizer session before we dive into anomaly detection. We're going to play a little game to get our minds thinking about patterns and how we can spot things that don't quite fit. This game is called the Classification Quest, and it's a fun warm-up for the brain. Let's get started. I'm going to show you an image, and your job is to count how many chihuahuas you see. Sounds easy, right? Well, the trick is there are muffins in the image too, and some of them look quite similar to the chihuahuas. Think of this like a model used for identifying things in data. Just like a computer learns to spot patterns, today you'll be the one spotting chihuahuas in this picture. Take a close look, and when you've got your number, raise your hand or type it in the chat.
How many chihuahuas do you see? How many poodles do you see?
Great job, everyone. You've done an excellent job spotting the anomalies. Some of them were easier to catch, while others required a bit more thought. This warm-up shows us how anomalies in data can sometimes be obvious, but other times they're hidden within broader patterns, and that's exactly what we'll be talking about in today's session. How to use anomaly detection to find those outliers even when they're hard to spot. Now that our minds are warmed up and ready to go, let's dive into the main topic of today's session, anomaly detection in NHS financial data. We'll see how the same skills we just used to spot patterns can help us detect inefficiencies, fraud, and unusual transactions within the NHS. Let's begin. Let's first talk about what anomaly detection actually means. At its core, anomaly detection identifies data that stands out from what's expected. For example, if we expect certain monthly expenses to stay within a specific range, and suddenly we see a big spike, that's an anomaly. There are different types of anomalies, like single, unexpected events, or patterns that don't fit the broader context, such as irregular spikes in procurement during certain periods. This is highly relevant to the NHS, because with so much financial data flowing through the system, it's easy for unusual activity to go unnoticed. Now, why is this important for us in the NHS? Well, as finance professionals, we're always looking to manage costs, detect fraud, and avoid inefficiencies. Anomaly detection can help us identify where money may be leaking from the system, where inefficiencies are happening, and where there may be instances of fraud. In short, anomaly detection helps us stay on top of our financial performance, ensuring every pound spent delivers value and stays within expected boundaries. Let's look at some examples of common anomalies we might face in NHS finance. These could be irregular or unexpected expenses, procurement overruns, or even suspicious claims. For instance, if you notice a sudden, unexplained increase in spending on supplies, that's an anomaly worth investigating. In public healthcare systems worldwide, this kind of data analysis has helped uncover areas where spending has spiraled or where fraud has occurred. By detecting these anomalies early, we can take corrective actions before they become larger problems. Now, I won't dive too deep into the technical side, but I do want to give you a sense of how this works. There are two main ways anomaly detection can be applied. In supervised learning, the system is trained with examples of what normal looks like, so it can recognize anything unusual. Unsupervised learning, on the other hand, doesn't need pre-labeled data. Instead, it detects patterns that deviate from the expected without being told what normal looks like. For us, this means anomaly detection systems can be flexible and adapt to the wide variety of financial data the NHS generates. Let's walk through how a typical anomaly detection model is built. First, we collect and prepare the data. This might be transaction records, procurement data, or even payroll information. Next, we train the model to understand what normal looks like by showing it historical data. From there, the model identifies unusual patterns or outliers. Lastly, it flags these anomalies for further investigation. While this sounds complex, the key takeaway is that once set up, these models run automatically, saving time and catching anomalies you might otherwise miss. How does this work in practice? One of the most valuable applications is in detecting anomalous transactions in procurement. For example, if there's an unusually high number of orders from a particular supplier or a sharp increase in prices, the system can flag this for review. In addition, machine learning can automate parts of the audit process, meaning we can identify potential issues more quickly and reduce the risk of human error. It's an extra layer of oversight that can significantly improve how we manage finances across the NHS. Fraud detection is another critical application of anomaly detection. In an organisation as large as the NHS, with thousands of suppliers and transactions, it's easy for fraudulent claims or overbilling to slip through the cracks. Anomaly detection systems are designed to pick up on these unusual patterns. For instance, if a particular contractor consistently overbills or submits irregular claims, the system can flag it for investigation. There have been cases in other public healthcare systems where anomaly detection helped prevent significant financial losses by identifying fraudulent activity early. Of course, like any system, anomaly detection has its challenges. One common issue is data quality. If the data going into the system is incomplete or incorrect, it can lead to false positives or, even worse, missed anomalies. In the NHS, we also deal with an enormous amount of data, which can make it difficult to spot the important signals amidst the noise. However, the good news is that with regular data maintenance and a well-tuned model, these challenges can be overcome. To overcome these challenges, we need strategies in place. Improving data quality is key. Standardizing data formats, regularly cleaning and updating datasets and ensuring accuracy. Another strategy is to regularly adjust the models so they stay responsive to changing patterns. For example, the financial landscape during the COVID-19 pandemic looked very different from normal operations, and models need to reflect these kinds of shifts. With these strategies, we can make anomaly detection more effective and reduce the noise of false alarms. Looking forward, anomaly detection has the potential to transform how we manage NHS finances. Beyond just detecting current issues, it can be used for predictive analytics, helping us forecast where costs might spiral in the future or where resource allocation could be optimized. By integrating anomaly detection into our everyday financial systems, we can improve transparency, accountability, and overall financial performance. The future is really about making data work smarter for us. Now, let's walk through a complete worked example step by step. We're going to follow a structured process starting with data quality checks, then exploring the shape and behavior of the data, before applying anomaly detection techniques and simulating the potential financial risk exposure. This example is designed to reflect a realistic NHS procurement scenario. The goal isn't just to find anomalies, it's to show you the full life cycle, from messy-looking data to meaningful insights and actionable recommendations. At each step, we'll explain what was done, why it matters, and how it supports internal audit, counter fraud, or financial planning objectives. Let's get started with step 1, data quality assessment. Now we move from concept to execution. This is where things get interesting. The dataset we're using contains 1,000 procurement transactions. Synthetic, yes, but closely modeled on real NHS data structures. Every record includes a transaction ID, date, customer ID, category, and amount. This forms the foundation of our anomaly detection pipeline. The goal here, spot what doesn't belong and understand why. Before we jump into analysis, we need to ensure our dataset is fit for purpose. We assess it across all 6 government-endorsed data quality dimensions. And the verdict? This data ticks all the boxes: accurate, complete, consistent, and, importantly, valid and timely. With unique transaction IDs and no missing or malformed entries, we're ready to proceed with confidence. Here's the continuation of our data quality review. The date field behaves as expected. No future dates, no ancient ones from 1993. All values fall within a reasonable range, and category labels are standardized. Bottom line, this data is well behaved and ripe for anomaly detection, forecasting, or even financial risk modeling. Next, we explore. This is about getting a feel for the shape of the data. We look at distribution, trends, and standout features. We're dealing with a broad financial range, from minor purchases of under £1 to high-value transactions brushing £192,000. The average transaction is just over £1,000, but there's a lot of variance. Here's the first thing that jumps out: a classic long tail. The majority of transactions are small, routine, expected. But that long tail of high-value transactions, that's where our anomalies will often live. This shape is common in procurement. Lots of low-cost routine items, punctuated by occasional big-ticket spends. Most activity centres around core operational categories, things like waste disposal, cleaning, and transport. But there's one category that doesn't quite belong, a deliberately inserted, anomalous category. It's low in volume, high in spend, and that's precisely the kind of red flag we want our models to pick up. When we chart this monthly, we start seeing patterns. Procurement doesn't follow a flat line. It reflects real-world rhythms. Year-end peaks, post-winter dips, summer slowdowns. This chart helps establish baselines and control limits. It also hints at where to look when something breaches expectations. Here we highlight the control chart approach. The green line is our mean, red lines are 3 standard deviations, up and down, our thresholds for special cause variation. No points breach the red lines in this view, but some months hug the upper limit, and that warrants a closer look. Let's drill in. October 2021 is notable, driven in part by a transaction of nearly £500,000, again from that anomalous category. It's joined by genuine categories like IT and energy. So it's not just the fake data doing the heavy lifting here. We also see some repeat appearances from HOSP 999, our synthetic department. And now for the dips. Here we see quieter periods, likely reflecting operational slowdowns, summer holidays, year-end budget controls. These insights are useful for seasonal forecasting and to highlight when things go unexpectedly quiet. Silence can be as anomalous as spikes. Now to the heart of the method, DB-scan, a density-based clustering algorithm. What does that mean in simple terms? It groups transactions that fit together and flags the loners. The ones that don't cluster, those are our potential anomalies. We use this to analyze a sample of 1,000 transactions. Here's what it found. 12 transactions stood apart. Just over 1% of the data, a manageable review burden. These weren't just random spikes. They occurred in well-established categories like IT and energy. That's key. Even familiar categories can conceal outliers if the timing or spend diverges from the norm. Once we know what's odd, The next question is, how much could it cost us? Enter Monte Carlo simulation. This approach lets us simulate hundreds of possible outcomes to model the risk range. If these 12 anomalies were symptoms of something bigger, what might the financial exposure be? Here are the simulated outcomes. At the low end, the risk is just under £56,000. At the upper end, it's over £60,000. This range helps us plan. It tells us whether we need budget buffers, supply reviews, or deeper dives into related categories. It quantifies uncertainty, and that's powerful. Here's the recap. From our DB scan run, 12 transactions stood out. Categories involved weren't obscure. That's what makes this real. This isn't catching outlandish spending in unknown areas. It's catching unusual spend in places we think we know well. And that's exactly where audit adds value. Finally, the takeaway. While we can't say for certain that these are fraudulent or inappropriate, they merit further scrutiny. The recommendation: review the flagged items, check documentation, validate against contracts, and perhaps most importantly, embed anomaly detection into routine oversight, because what we don't measure, we can't monitor. In conclusion, anomaly detection is a powerful tool that can help us maintain control over NHS finances. It not only helps us catch inefficiencies and fraud early, but also supports continuous improvement by giving us the data-driven insights we need to make informed decisions. As finance professionals, leveraging anomaly detection allows us to ensure that every pound is well spent and we can focus more on delivering value for patients. Thank you for your attention, and I'm happy to take any questions.
Thanks, everyone. That's the second time Archer has been let loose as far as running my presentation is concerned. Hopefully that was informative. Now just an opportunity really from the group to take any questions about the presentation. This isn't just focusing on existing systems, it's focusing on machine learning and AI tools and techniques that can be used in any organisation, providing you've got the knowledge, skills and experience and the capability and capacity to actually deploy some of the measures talked about today. So just hopefully we may have some questions, or we can have a further discussion. Simon?
Yeah, I thought I'd ask a question.
Your volume's quite low, Simon. My apologies.
My headset.
There we go.
There we go. I just thought I'd ask a quick question. So we currently hold a lot of our transactions on a SQL database. So
Yeah.
I'm assuming it'd be quite simple to apply some of these techniques to that sort of data, because now we've got it in that sort of format. Would it lend itself well? I mean, I'm just thinking, what sort of systems do people need to deploy these sorts of algorithms in terms of the anomaly detection?
So if you look at the standard setup at the moment, so are you actually on the NHS tenant as well as having your own data warehouse?
Yeah, I think so.
So normally what you could do is from your SQL backend, you could then build a data pipeline through into the NHS tenant, and then deploy the models as part of the extraction, transformation and load process.
Okay.
That is something that your tech teams, or if you've got data engineers already working in your organization, that should be something that they can support you with. So yeah, this should be pretty simple to deploy those models in a data pipeline from your existing data warehouse.
Yeah, because I think my question sort of almost refers back to, in a finance context, you've got a lot of transactions, haven't you? But across the NHS, there's lots of different platforms people use, everything from spreadsheets all the way up to, like, say, warehouses. And it's like, what's the best way forward in terms of doing this? Because obviously you need your data in a certain format, I guess, to apply a lot of this. Would you be able to do it in a spreadsheet, for example? That's another question.
So again, depending on the how much you want to get involved, Simon. So obviously Python now sits in Microsoft Excel. and Python is a programming language which can be used to prompt some of these models to run on data. You've also got the ability, if you've signed up to Copilot Enterprise, Copilot Enterprise can run similar algorithms within the Office suite of applications. So yeah, it can be run from something as simple as a spreadsheet up to a SQL instance sat on a SQL server.
Yeah, thank you.
I think there was another hand. Any more questions? Now, hopefully, as I said, that's been informative. I'm more than happy to catch up after the session today if any questions do arise. They were just some of the examples today that maybe prompt your thought and will get you speaking to your technical teams within your own organizations about how some of these algorithms can be used for anomaly detection. Certainly in our space, a lot of counter and preemptive fraud activity is being carried out using anomaly detection with AI-driven automation that sits behind it for workflow notification. So this isn't something that you need inherently baked into your financial systems, whether that be Oracle or another system. These are algorithms that can be deployed from wherever the data is stored, and as Simon just said, whether that's an Excel spreadsheet or a SQL instance in a data warehouse. So yeah, happy to catch up offline. I'm sure my details will be made available after the session. Thanks for listening today. And yeah, hopefully we'll get an opportunity to engage again in the future.
Thank you so much, Andrew. Thank you.